Hey guys, today we're going to conclude chapter 4 with the last section, section 6, called L'Hopital's Rule. And L'Hopital's Rule is going to be used when you go to find a limit and you get what is called the indeterminate form. And the indeterminate form is mainly going to be 0 over 0 or infinity over infinity. Now, some of these others could also be used, but the first two are typically what you're going to see. So basically, what I just told you is the information that you see here, which I have put in your big box. So here are your steps. Just like the last section, I'm just going to jump right into the problems. I think once I do that and you go back and read the steps will make a little bit more sense to you. So as we look here at problem number 1, we begin the process by setting up the limit as x approaches 5 of the numerator and finding that value, and then setting the limit as x approaches 5 of the denominator and finding that value, which here we know very quickly is 0. So just real quick, 2 times 5 squared minus 9 times 5 minus 5 is 0. And in order for L'Hopital's rule to work, 0 and 0 is what you would find here, or infinity and infinity. Now, the way that we're doing these problems is the way that you would need to do them on the AP exam. And I know as you're looking at this, you're kind of going, I'm not sure I need to do all of that. In order for you to get full credit on a problem that would use L'Hopital's rule, you would need to make sure that you do all the steps. So in step 2, we say that we are indeterminate, 0 over 0. So by L'Hopital's rule, and that's all you have to do for step 2, and you're going to do it for every one of them. Now we do the limit as x approaches 5 of the function, the original function, and we make that the limit as x approaches 5 of the derivative of the top and the bottom individually. So 4x minus 9 over 1. So we'll make a note of that. To go from here to here, you take the derivatives of the top and bottom individually. So all you would have to do in step 4 is your substitution for your limit. So 4 times 5 minus 9. And in step 5, you declare your answer, which is 11. If you would like to pause your screen and try example 2, you're going to be doing the exact same thing. So the limit as x approaches negative 5 of the top, square root of 4 minus x minus 3. So the square root of 9 is 3. 3 minus 3 is 0. And the bottom is clear to see 0. So we say it is indeterminate. So by L'Hopital's rule, remember the next step, limit as x approaches negative 5 of our function and we are going to make that the limit as x approaches negative 5. The bottom is 1, but we have got to take the derivative of the square root of 4 minus x minus 3. So that's 4 minus x to the 1/2 power minus 3. Negative 3 is going to have a derivative of 0. So bring down minus 1 times the derivative of the inside. Don't forget that. just -1. I'm not sure where I put that square in there. So -1 over 2 square root of 4 minus x. And that's over 1. So we can declare that as our derivative of our numerator. Denominator derivative is 1. All right, substitute. And you get -1 over 6. So what happens if you go to do a problem, and once you have completed it, you get 0 and 0 again, or you get infinity, infinity again? So that just means you use L'Hopital's rule again. The process stays the same. So the limit as x approaches negative infinity of x squared is just infinity. And the limit as x approaches negative infinity of e to the negative x will also be infinity. So there's your indeterminate form. So by L'Hopital's rule, time for our derivatives. Two x over negative e to the negative x. Set up your limit of the top. Again, negative infinity here. And negative infinity here, 3 negatives. So again, it's indeterminate. So you just repeat the process. So break that up. This would be 2 over e to the negative x. So 2 over e to the infinity is 2 over a large number. So that value would approach 0. If you guys would like to try this one's a polynomial, so it's not too bad. If you would like to pause your video and try it, feel free. So the limit as x approaches -2 of your numerator and when you plug in -2, you get 0 in your denominator. And again, I'm just saving time here. I've already done these calculations. Don't just assume that they're going to be 0. Just because we're in section 6 with L'Hopital's rule, don't just assume that they're going to be 0. You still need to make sure that you check. So indeterminate by L'Hopital's rule. Derivatives on the top and on the bottom. Separate them. Numerator and denominator. So that one's going to be 0 again. And 0 again. So indeterminate. So by L'Hopital's rule, set up your limit. 3x squared plus 2x minus 8 over 3x squared plus 16x plus 20. Derivatives, 6x plus 2 over 6x plus 16. This time we should be able to plug in -2. And get -5/2. So sometimes you just have to repeat the process to find your limit. Type 3, trig functions. You don't do anything any differently. So the limit as x approaches 0 of sine x times 1 minus cosine x. And the limit as x approaches 0 of x squared, which we know is 0. On the unit circle at 0, you have 1, 0. So cosine, sine, so sine of 0 is 0. Indeterminate. So by L'Hopital's rule, limit as x approaches 0 of our function derivative of the top and of the bottom, but we are going to split this up into trig limits instead of doing the derivative of the top and of the bottom. And I'm going to show you what that looks like. So that makes it much, much easier. Cosine times sine, plug in our 0. And 1 times 0 is 0. Derivative of sine is cosine. Derivative of x is 1. Derivative of negative cosine is sine. Derivative of x is 1. Taking a look at number 6, the limit as x approaches 1 of your numerator, and the limit as x approaches 1 of your denominator. So ln1 is 0 minus 1 plus 1, 0. E to the 1 is e minus e is 0. So we are indeterminate. And guys, notice, because I know some of you like to cut corners, there are no abbreviations here, and you need to get used to that because on the AP exam, they're not going to know what your abbreviations are. So you need to make sure you're filling everything out. Make sure you put your function here. Don't just call it f of x. We don't know what f of x is in these problems. Find your derivative. Ln x becomes 1 over x minus 1 over e to the x. Plugging in 1 over 1 minus 1, 1 minus 1 over e to the 1 is 0. All right, the limit as x approaches infinity of the numerator would be infinity, and of the denominator, also infinity. Indeterminate, so by L'Hopital's rule, x approaches infinity of your function. Find your derivatives. Notice that as x approaches infinity, you're still going to approach infinity. So 18x plus 10 is infinity, and 24x is also infinity. So use the limit as x approaches infinity rules, which are the same as your horizontal asymptote rules. So this limit at x approaches infinity would be 18 over 24. Degrees are the same. Degrees are the same. So 18 over 24 is our limit, which reduces to 3 over 4. So I will circle that for you so that you see where those come from. And that's what goes there. If you would like to try this one by yourself, feel free to pause the video. The limit as x approaches infinity of 4x squared minus 3x plus 2 is infinity. The limit as x approaches infinity of e to the 2x plus ln x, also infinity. So indeterminate, by L'Hopital's rule, so 8x minus 3 over 2e to the 2x plus 1 over x. You do have the option, if you want to say this is f of x and this is g of x, and then to say this is f prime of x and g prime of x. As long as you establish that, then you can use that notation. So f prime of x is still going to be infinity. You may find that saves you some time. G prime of x is still going to be infinity. So we're still indeterminate. So we're going to do L'Hopital's rule again. So the limit as x approaches infinity of 8x minus 3 over 2e to the 2x plus 1 over x. This would be 8 over 4e to the 2x. X to the negative 1 will be negative 1, x to the negative 2. So negative x to the negative 2. This is going to be 8 over a large number. We've already had experience with that, which leads to 0. We're going to start looking at some AP type problems, starting with number 9. The table below gives values of a twice differentiable function, f of x. Use the table to find the limit if it exists and justify your answer. So the limit as x approaches negative 2 of f of 3x plus 2 is f of negative 2, negative 6, negative 4. So f of negative 4 is 0. And the limit as x approaches negative 2 of x squared minus 4, also 0. Indeterminate. So by L'Hopital's rule, do your derivatives. So this is f prime of 3x plus 2 times 3 over 2x. The 3 comes from the derivative of the inside. That would be step 3. Step 4, 3 times f prime of, sorry, these are negative 2's, negative 4 over 2 times negative 2 is 3 times f prime of negative 4, which is 8, over negative 4, which is negative 6. Now, one thing that we do on our notes, just because it's easier, is we box our answers. On your AP exam, you don't want to box your answers, because what happens is when you box your answers, your grader goes straight to the boxes. If you have correct information, but you've boxed an incorrect answer, you don't get credit. So we don't want any boxes on the AP exam. Use the graph of y equals g of x to find the following limit. If possible, use proper notation to justify your findings. So the limit as x approaches 3 of g of x. So as x approaches 3 of g of x is 2. So we haven't seen that yet. And the limit as x approaches 3 of x minus 3 is equal to 0. So the limit as x approaches 3 of g of x over x minus 3 is 2 over 0. So this value does not exist. L'Hopital's rule does not apply. Why does it not apply? Because you don't have indeterminate form. You don't have 0 over 0. You have 2 over 0, which is an undefined value. The differential equation for the curve y equals h of x is given by dy dx equals 3x over y plus 2. Given that h is twice differentiable and h of 3 is negative 1, find your limit that you see here. All right, the first thing that we want to do is say our limit as x approaches 3 of h of x plus x minus 2, and the limit as x approaches 3 of ln of 7 minus 2x. I'm going to do this part first just because it's a little easier. Ln of 7 minus 6 is ln of 1, and ln of 1 is 0. All right, h of x, plugging in 3, would be h of 3. And h of 3 is negative 1 plus 3 minus 2. is 0. So we are indeterminate. By L'Hopital's rule, limit as x approaches 3 of your function. And break it up into your derivatives. H prime of x plus 1 over derivative over your function. So this is h prime of 3 plus 1 times 7 minus 2x over negative 2. Now, to find h prime of 3, we plug these values into dy dx. So x is 3 and y is negative 1. So that would be 9 over 1, which is 9. So 9 plus 1 times 1 over negative 2, 10 over negative 2 is negative 5. It's pretty big numbers here for problem number 12. It doesn't mean you do anything any differently. Obviously indeterminate here. So if we were to take this and find each derivative, and find each derivative again, and find each derivative of again, what's going to happen is it's not going to change our values. So we can just say this value does not exist because we are going to continue and continue and continue to get infinity. All right, guys, this concludes chapter 4. As always, let me know where your questions are. We'll be having a test soon. Hope you guys have a great day.